we present Unpacking Failure Modes of Generative Policies, Runtime Monitoring of Consistency and Progress. Consider the problem where you would like to teach a robot to solve a manipulation task, for example, to close a box with 3 lids. To do so, you collect a dataset of expert demonstrations and then train a generative policy, like a diffusion policy, to predict a sequence of actions that will solve the task. The generative policy has advantages. For example, it can fit multiple modes of solutions contained in the demonstration data. After training the policy, you validate it on nominal test cases and see that it works as expected. However, when you deploy your policy, you find that subtle distribution shifts may cause it to fail. Moreover, you observe that the generative policy fails not only in one way, but in several different ways. For example, it may fail smoothly or fail to recover from a wrong action. It could collide with the box or exhibit unsafe failing behavior. Therefore, the objective of this work is to design a failure detector that can catch diverse failure modes of learned generative policies. That is, we would like to detect in which trajectory a policy will fail at the earliest possible time step. Our core idea is that we can split the failure detection task into 2 complementary categories of failure, each of which is assigned to a specialized detector. Then, we can combine these specialized detectors to form a performant overall runtime monitor. The first failure category is erratic failures, cases where the policy exhibits temporally inconsistent behavior, which may cause the robot to bump into objects or end up in undesired states. In this work, we propose an efficient temporal consistency detector to catch erratic failures fast. The second category is task progression failures, cases where the policy struggles to make progress on its task, but does so without behaving erratically. We propose the use of vision language models to detect task progression failures. To detect erratic policy failures, we propose to measure the statistical temporal action consistency of the generative policy. We start by computing the policy distribution at each time step. We then compute a statistical distance between adjacent policy distributions to measure temporal consistency. This process is performed throughout the policy rollout. To detect failure at the current time step, we sum the temporal consistency scores and check if the sum exceeds a calibrated detection threshold. If it does, the detector raises a failure warning. To detect task progression failures, we propose to query a vision language model zero-shot to assess whether or not the policy is making progress on its task. To gauge task progress, the VLM must reason across time and in the context of the policy's task. Thus, we construct a prompt that includes the history of image observations up to the current time step and a brief description of the robot's task. The prompt is fed to the VLM, which classifies failure after performing chain-of-thought reasoning. Our full failure detection framework runs the temporal consistency detector and VLM runtime monitor in parallel. Execution of the policy stops if either detector raises a failure warning. We evaluate our framework on the multimodal push-T domain and 2 bimanual mobile robotic manipulation domains. These domains feature different types of distribution shifts and policy failure modes, among other properties. Specifically, we test our framework's ability to detect failures of diffusion policies trained on these domains. We find that our temporal consistency detector, STAC, is able to effectively catch erratic policy failures, in contrast to a baseline whose cumulative errors do not exceed the detection threshold when the policy is failing. As expected, STAC struggles to detect task progression failures when the policy behaves in a temporally consistent manner. In contrast, VLMs are able to identify that the policy has failed to complete its task, thus highlighting the complementary nature of STAC and the VLM runtime monitor. To summarize, we study the problem of failure detection for generative policies, which fail in diverse ways beyond the training distribution. Our core idea is to split the failure detection task into 2 complementary failure categories. The first category, erratic failures, are detected with a new temporal consistency approach. The second category, task progression failures, are detected with vision language models. Combining these 2 detectors results in a framework that can contend with diverse policy failure modes. We hope to spur continued research interest in runtime monitoring for learned robot policies.